Perforce. Let's talk about it. So if you've been in the gaming industry for a while, or even if you're relatively new to it, you've probably heard of something called Perforce or P4. Now, when most people are referring to Perforce, they're talking about the version control software from the company Perforce. Now, let's do a brief recap on what version control is in the first place. Well, the key goal with version control is that you're able to version or save your software and effectively collaborate with others on it, right? So for an example, let's assume that you and your friends are trying to collaborate on a paper. Everyone needs to write a different section of the paper. You want to make sure that people aren't accidentally overwriting different portions of the paper, and you want to be able to revert to previous versions if you need to. Well, this is the same goals or the same things that you'd be looking for with version control. With traditional software development, this is usually achieved with technologies like Git and Git providers like GitHub and GitLab. So why Perforce? You might be thinking, well, with Git, I can get everything that I'm looking for. I can get the version control functionality, I can get the collaborative nature, I can roll back to previous versions of what I'm working on. Why might I want to use something like Perforce? Well, let's kind of talk about some of the challenges of game development. Game development is complex, and the files are larger than you typically would have with traditional software development. So let's think about a standard web application. It's probably going to have some HTML, CSS, and JavaScript files, maybe some compressed images and some video, but that's usually going to be the majority of what you're dealing with, so relatively small files, right? Now compare that to a video game, which can easily have file sizes in the tens of gigabytes of storage, sometimes hundreds of gigabytes of storage. And what's really leading to those larger file size are the assets. So you have things like all of the textures for all the buildings themselves, the trees, the water, the skins, everything that comprises of what you see and what you hear in the game, right? And all of that adds together and can easily lead to larger file sizes. Now with Git, you can deal with larger files with things such as Git LFS or Git large file system, but it really wasn't made for that initially. Whereas Perforce was purpose-built to handle these larger assets that you typically deal with in the game development process. And with all these variety of different assets, you usually have different teams that are working on these, right? So you need that easy collaboration, right? You might have an art team that's creating the actual 3D models and the character designs. You might have the audio team that's making or doing the sound design and composing the actual music for the game. And then the development team that's actually creating the game mechanics and combining all these assets together. But these individual teams might be geographically distributed, right? But you still need to make sure that everyone can effectively collaborate together. So now that we've talked about version control, game development, and why you might want to use something like Perforce, let's talk about how you can get this up and running on something like AWS. It's understandable that as a new studio or even a more established studio, this can be somewhat of a daunting process, right? There's a number of tools that you have to stand up and maintain to keep things afloat. Now, I'm a firm believer that technology is really put to best use when it gets out of your way, right? Where it makes things easier for you to accomplish your goals. And it doesn't become a blocker that makes it harder than it needs to be. And in the nature of this, we've created the Cloud Game Development Toolkit. Now, the Cloud Game Development Toolkit is a set of templates and Terraform modules that makes it easier for game studios to deploy these tools on AWS. We have modules like Perforce, Unreal Horde, Jenkins, Unreal Cloud DDC, TeamCity, and we're actively adding more features and functionality every day. It's an open source project, and we're really passionate about adding in the features and functionality that are going to be most beneficial to game studios. So definitely, if you're interested in contributing, we're really open to PRs or even feedback to let us know what you'd like to see. In this video, we're going to be focusing on Perforce and how to use the Cloud Game Development Toolkit to deploy Perforce on AWS in just a couple minutes. Let's hop right into it. All right, so I'm over in the repository for the Cloud Game Development Toolkit, Like I mentioned, the Cloud Game Development Toolkit is a series of templates and Terraform modules that makes it easy for you as someone at a game studio to deploy your relevant workloads, right? There's a lot of things that are in here, but what we're going to be focusing on today is Perforce. So I'm going to go into modules, and within modules, I'm going to go into Perforce, and we'll talk about the architecture. We'll talk about what this module currently deploys. Right now, that would be P4 Server, which is formerly known as helixcore, P4 Code Review, which is formerly known as helixswarm, and then P4 Auth, which is formerly known as helixauthenticationservice. So in terms of, before we get into the architecture, just from some of the structure, and we'll get into this a little bit more when we actually deploy the solution, as with all the other modules, there's going to be examples. So showing you how to actually use the module in a variety of different configurations to deploy it in the manner that you want. And then there'll be, your core configuration files. This module also uses submodules. So P4 Auth, P4 Server, and P4 Code Review are all submodules in this root Terraform module. And those could be independently consumed if you just needed one of the three. But the standard deployment that we are going to be using today is deploying all of those three together. Okay. So in terms of the architecture, let's dive into kind of the core components. And the way that I like to focus this in first is to talk about the compute, because that's pretty much the meat of what we have going on here. So we have Amazon EC2, which is basically a virtual machine running in AWS. And then we also have some EBS volumes. Now, Amazon EC2, like I mentioned, is going to be the actual compute for the P4 commit server. And then Amazon EBS, or Elastic Block Store, that's going to be used for the actual volume, so the data storage, right? So for the depots, for the logs, and then for the metadata, that's where these EBS volumes are going to be used for. Okay. And then the next components that we have, right, for P4 Server and P4 Code Review, those are both going to be services running using Amazon ECS, or Elastic Container Service, right? So within this, we have an ECS cluster, and then in this cluster, we have two services that relate to each of those, right? So one for P4 Auth, as you can see here, and then one for P4 Code Review. Now, it's important to note that right now these both have just a single task in each, because they, I don't believe P4 Auth or P4 Code Review support horizontal scaling, but this is going to be more than enough for our use cases, right? So those are the two compute, components that we have here. So EC2 and the EBS volumes for the data storage, and then ECS cluster, and then the services for P4 Auth and P4 Code Review. Now, with that out of the way, let's kind of talk about some of the connectivity in the data flow, because it's also really important for this architecture. So starting on the left here, we'll have you as a developer or an artist or someone that needs to use Perforce. How are you going to actually be connecting to do what you need to do? Now, what we're going to be doing in this use case is having a Route 53 public hosted zone. Now, if you're not familiar with Route 53, it's basically DNS service in AWS. It can be used as the DNS registrar itself. So, hey, you want to maybe go buy a domain and have that up and running. But it can also be used for DNS resolution itself too, right? Really powerful service. A lot of stuff you can do even with hybrid connectivity, but that's getting a little out of scope of today's video. But public hosted zone is what we're going to be using to make this a lot easier of a process. And what this is going to be doing is handling the resolution, right? When we have requests that are for, and we'll explain this in a little bit, but for perforce.example.com, example.com just being, you would replace that with whatever actual domain you want to use with this, or auth.perforce.example.com, or review.perforce.example.com. This public hosted zone is going to be handling that initial routing of where these requests should go. So path one is basically you need to connect to the Perforce server. So what would happen is you would have a request for perforce.example.com, and inside of this public hosted zone, there would be a record that would handle that request. So, with an Amazon EC2 instance, you would have a public IP address, and then you would have a private IP address. But to ensure that we can always have connectivity, what we have is an elastic IP address. It's basically a static public IP address that will not change. So in this public hosted zone, there's a record that would forward requests for perforce.example.com. Again, replace example.com with your specific domain. It would forward those requests to the Elastic IP address, and that's how you would have connectivity to that Amazon EC2 instance. So that's the first kind of level of connectivity, but you also likely either directly or indirectly need to access the services, right? So for P4 auth and P4 code review. And that also is going to be using the public hosted zone. So I believe the way this is currently configured is there's a wildcard. So basically an asterisk dot perforce.example.com, and it's going to send effectively any other request that is not perforce.example.com to this network load balancer. And this is a public network load balancer. Now, this public network load balancer is going to have a listener that's going to be listening for HTTPS requests, because we want to make sure we're using secured and encrypted connectivity. And what that's going to be doing is basically it's going to be forwarding that to a target group. So a target group with a load balancer is just a destination for where you want that traffic to go. And in the case of this public network load balancer, the target group is going to be a private application load balancer. So this is where that transition from public connectivity to private connectivity is going to happen, is right here in this transitional piece. Now, it's not shown on the architecture, but this private application load balancer is actually going to have an SSL TLS certificate that's attached to it. And that's, important again, because, we're using that HTTPS traffic here. Now, once the traffic reaches this private application load balancer, the application load balancer needs to be able to effectively send requests to the relevant services. And the way that's being done is using host-based routing. And that's, different than something like path-based routing. So if we kind of look at, say, just this URL here, right? We have github.com/AWS-games/cloud game development toolkit, et cetera, right? Those slashes are paths, right, that are basically getting more specific for the actual endpoint or the URL that you want to access. But what we want to do is we want to use the specific host space or the subdomains, right? So we want review, and again, this is configurable in the module, but by default, review.perforce.example.com or your domain. It's going to route those requests to the review.service, so P4 code review, and then auth.perforce.example.com. Those are going to go to the P4 auth service, right? So it's using that host-based routing to route requests effectively to the services, okay? Now, these services also need to communicate with the server itself, right? These are all pretty highly connected together, but these are in, as you can see, private subnets, right? So how do we allow for this connectivity? Well, in this scenario, we're using a Route 53 private hosted zone. And this private hosted zone is going to have records that would allow the services in this ECS cluster to talk to the EC2 instance for the P4 commit server. And this will make a lot more sense when we actually get this deployed and we kind of look at some of what's in the public and private hosted zone and a little bit of the configuration. But that's really the majority that you need to know about this architecture. An important thing to note, which I might have mentioned a little bit earlier, but this Elastic IP address, since this is a public static IP address, you could also just directly use this to connect. But for simplicity's sake, especially in terms of these different subdomains and routing to the specific services, this is why we're leaning into DNS resolution to make this process easier and more scalable and a little bit more secure. All right. So with that being said, let's go ahead and we'll actually hop into VS Code and let's get this deployed. All right, so I'm over in VS Code, and similar to what we were seeing in GitHub, we have our expected directory structure. Really, to get to this point, you would basically just need to clone the repository locally and open it up. You could also optionally fork the repository if you might want to make maybe some modifications. With this being an open source project, feel free if there's something that you kind of want to customize and custom tailor it for your specific use case, or even you want to submit a PR back to the core toolkit repo. Always looking for contributions, but I'm going to leave this as is, and I already have this clone locally, so I'm just going to use it from this point on. So the core that we're going to be focusing on today for the deployment are two things. we're going to be using the assets directory, and then we're going to be using the modules directory, specifically the Perforce module within that. So as I mentioned in the architecture, one of the core components in terms of the compute that's actually going to be running this is an Amazon EC2 instance. And that EC2 instance is a virtual machine. So that virtual machine is going to need some sort of image that is actually built and configured to run what you need it to run on there. So what we're going to be configuring this EC2 instance to have on it are the related resources for Perforce. So we need to build this Amazon machine image for future use by the module to actually provision that Amazon EC2 instance for Perforce. And we've actually provided a HashiCorp Packer template to make this easier for you to deploy. So inside of assets and then Packer and then Perforce, there's two key ones. This is really just an example, but we have ARM64 equivalent for that architecture. And then we have an x86 for that Intel-based architecture. There's also some scripts that will run as a part of the build process. So effectively with EC2 instances, you have user data, which are basically, you can have some scripts that are used for additional configuration. And that's currently in this version of the toolkit what we're using for configuring the AMI. Now, by default, the module is going to default to x86 for all the compute resources, so the EC2 instances, and then for the ECS cluster and the services is all going to be x86 unless you change that. It is customizable if you want to use something else. But just make sure specifically, or especially for this EC2 instance, that you build using the specific AMI architecture, using the specific architecture for your instance. So like I said, by default, if you don't make any changes to the module, you want to use the x86 equivalent template. But if you did overwrite that default value and use ARM64, that's the one that you would need to be using. Okay. So there's a couple of different ways you can do this. The easiest way is I'm just going to change directory into this P4 server directory, and then I'm going to run some Packer commands. So with that being said, right, a prerequisite is that you would need to have HashiCorp Packer installed. There's some links in the repo documentation to get that installed. Also, general prerequisite for this, as you would assume, you need to also have Terraform installed on your local machine, as well as an AWS account with IAM permissions that will allow you to provision the resources that are necessary for today. That's all set up for me, and I'm already authenticated into an AWS account. So let's go ahead and change directory into this Packer directory and for P4 server and get this installed. So right now I'm at the top of the repository, so I'm going to change directory into assets / Packer Perforce P4 server, and there we are, right? So I'm at this level here where I can see the shell scripts, and then I can also see the templates. So first, what I'm going to do is I'm going to validate the template that I want to use. So just make sure it's good to use. So I'm going to use Packer validate, and I'm going to validate the Perforce x86 template. So I'm going to run that, and the configuration is valid. Great. The next thing that I'm going to do is to initialize the that specific template. So I'm going to do Packer init, and I can pass in that specific name too to target that specific template. Make sure you do target the specific template if you're doing it this way. If you kind of have used Packer in the past and you just do like Packer init dot, that's going to fail because there's going to be conflicts between there's some names that are going to be the same in these two files. So just make sure you target the specific file. So we did Packer init and then that specific x86. And then the next thing we want to do is Packer build and also target that. So Packer build and then target that specific template. And now you can see it's going to actually go through the steps of creating that AMI. We're using the Amazon Linux, currently the Amazon Linux 2023 AMI as the base. And then we're going to be customizing that a little bit to install the things related for Perforce. So I'll give this a little bit of time, and we will let that go on and finish. Okay, cool. So it looks like that build successfully finished, and this is in the US East 1 region for me. By default, Packer's going to use whatever profile you're using is configured for. Mine is USD1 right now. So let's just validate that in the console real quick. So if I go ahead and I will flip over, if I look in, we'll just open up a new tab real quick, and I'm going to go into EC2, and I'll look for AMIs, and you can see I have this AMI here that's was created. So this is the one that I want to use for the EC2 instance for Perforce. All right. So with that out the way, now we can actually go ahead and deploy the module. And what the module is basically going to be doing is looking for that AMI and using that to create the EC2 instance, before it continues on and creates the other resources in there. So I can close this template. I'm going to just go ahead and do a clear, and I'm going to close these down, and let's go inside the module, right? So inside of modules, Perforce, let's use this example to help get this deployed easier. Like I mentioned, FSXN is also available instead of EBS if you want to use that for the storage, but for the sake of this, we're going to keep these simple and just use EBS or Amazon Elastic Block Storage. So inside of this, there's a couple of files, right? Let's start with main.tf. So we have this core module here for Perforce. Right now, the source is just local, right? It's pointing outside of the example directory to this module that is stored here, these Terraform code there. And there's a couple of different variables that I want to focus on. So the core ones are really for, if we kind of take a step back for what does this module deploy? Well, right now, the three things that are available are P4 server, so the actual commit server, P4 auth, and then P4 code review for those two services that are going to be related. And the way that we have this configured currently is we have variables that are used to define the configuration of these, right? So we have this config, P4 server config, P4 auth config, and then P4 code review config, right? Now, what's important to note is some of these values are already defaults, right? We kind of just left these here to make it easier to understand what's actually being created from the example level. But if we actually take a look into the module, and I highly encourage you, if you're thinking about customizing the module or maybe adding some additional things, definitely take a look at what's going on in there. But it's going to be in this variables.tf file. And you can see, for example, here for P4 server, we're using the optional functionality in Terraform, and basically saying, hey, if a user doesn't provide a value for this specific attribute inside of this object, then default to the value here, right? So in this case, if the name's not provided, it's going to be called P4 server. If you don't provide a project prefix, it's going to be CGD for cloud game development. Environment dev, etc., etc. This especially becomes relevant, as I was mentioning earlier, about the instance architecture. So by default, it's going to default to x86-64, which is why we built that Packer template that aligns with that. And then this is the actual instance that we want to use. Important thing to note, if you do change this, it's called out in the module README and stuff like that too, but if you change this instance architecture, just make sure the instance type that you choose also aligns with that. Some instances on AWS are going to align to the x86-64 architecture, and then some would be for the ARM64. So just make sure that you validate that these will be correct if you change them, but if you leave it as default, you should be all good to go. Similarly, for the EBS volumes, these are going to be the default storage sizes for the depot, metadata, and the logs, but that's also something that you configure. So definitely would take a look in here and then also look at the README to kind of see all these variables in depth. But that's basically what we're doing to make it easy to kind of do this configuration. Make all these configurable, set some default values, but again, the example level is more explicit than it needs to be. You really could remove a lot of these things and still have it deploy just fine, but good to be a little bit more explicit about some of these things. Okay, so we have this module and it's creating those resources, and you can see there's some references to other Terraform resources, right? So there's really a clear delineation between what the module will create and what a user would need to create. And in this scenario, one of the things that a user would need to create would be some of the networking resources. We found that a lot of organizations kind of standardize this, like there might be, a standardized networking team or, kind of a core cloud team that manages creation of VPCs and ensuring that the side arrays don't conflict with anything and things of that sort, right? So it's kind of out of the scope of the module to make the VPC and, those related networking resources, but the module pretty much will make anything else that it needs just for, successful deployment and operation. So what we're doing here is, if you look in some of these related files, like in vpc.tf, this is where we're actually creating the VPC, some security groups, subnets, etc., and then same thing related to like DNS and maybe some additional security resources. And then all we're doing is passing in those values for these variables as needed. If you already had an existing VPC and subnet and things like that you want to reference, well, you would just need to reference that specific value, right? So you can either just put in the specific IDs of the subnets that you want to use, or you could use something like a Terraform data source to fetch the value. You could fetch something, maybe that value is directly from the resource and you're using like the VPC data source, or maybe a parameter for these values in SSM parameter store, or maybe HashiCorp Vault. Really a lot of options. The main thing is just getting these values into the module is going to be the key thing that you'll need to do. All right, so that's what we're doing, is referencing those subnets that are going to be created in that vpc.tf. There's a couple of other things. I believe the subnets are kind of the majority of what we have here. Another thing to call out, right now we have this additional provider configuration for NetApp ONTAP. Is really only relevant for FSXN, but the way that the NetApp provider is currently configured, this is just a workaround that we have to have. Even though it's not necessarily used in this example, currently this is how we've gotten around that limitation with the providers, just effectively having the required values, but just setting them to just null, right? So it's not actually being used. But you'll see if you look at the P4 server for FSXN, these will actually use values that you pass in to configure the additional parameters that provider is going to be using. But just want to call that out if you see that and wonder why that's there, even if you're not necessarily using it for this example. Okay. The next thing that we want to do is let's look at the locals.tf, because you can see there's a lot of locals that are being passed into the module. So in locals.tf, this is kind of some of the core configuration for the module besides the direct variables. So we have things like the VPC CIDR block, the subnet CIDR blocks, some tags, and really the core that we want to focus on here is going to be your Perforce subdomain, P4 auth subdomain, and then code review. So like I mentioned when I was talking about the architecture, by default, we're leaving these as Perforce, auth, and review. So that way, effectively for whatever your top level domain is, so example.com for, just for an example's sake, what it would do is it would have for your related resources, subdomains of perforce.example.com, auth.example.com, and then review. And you can see these are being used for these additional locals, effectively to make it easier to make sure where relevant in the module, this same kind of structure is going to be followed, right? So you can see here for like the fully qualified domain name for P4 server, it's basically going to be perforce dot whatever the name of your Route 53 public hosted zone is, and so on and so forth, right? And like I mentioned, for the architecture for this specific example, a prerequisite is having a Route 53 public hosted zone. It's not necessarily a requirement to get this deployed, but then you would kind of have to do a little bit more of the DNS validation and things like that on your own if you were using a separate method for your DNS resolution, things like that. But we're going to be focused on Route 53 and that public hosted zone. You can see this configuration if we look at dns.tf. You can see what we're doing is a couple different things, but one of it is using a data source to find that Route 53 public hosted zone. And then this is where we're actually creating these records, right? So I'm creating the record that, like I mentioned in the architecture portion of this video, is using a wildcard for routing to the, the NLB, and then, through that to the ALB for the services. And then also for Perforce your domain name is going to be used for routing to the Perforce server. And then we have some things like a certificate and so on and so forth, right? And that's kind of the majority of what we have here. If we look at the variables.tf and the module itself, you can see is really only just one variable at the module level, which is the Route 53 public hosted zone name. Again, that's used because we're actually going to be fetching that related information with the data source that's in that dns.tf file, and then that's used heavily throughout the module as I explained, right? So a couple ways that you can go about setting this value. You could, which is what I'm going to do, is just set a default just to make this easy. I'm going to type in my the name of my public hosted zone. All right, and you can see that matches the public hosted zone that I actually have here. So this is effectively just an easy way to go about it. What you might want to actually do in, especially if you want to maybe do something that you want to test this out in development and maybe have like a development Perforce implementation and then separate from production, you would want to make a tf-vars file. So that's basically a way that you can define variables in a single file, and then when you run Terraform commands, you can actually target specific var files. Terraform will also by default just use either a file that's named terraform.tf-vars or a file that ends with .auto.tf-vars. It'll automatically load, but for the sake of making this easy, I'm just going to set this default here. Effectively, without this default, when you would run Terraform plan or apply, it would prompt you to type this in every single time. So I'm just setting this to make sure that I don't accidentally have a typo. If I have to, if I want to change something and do a reapply, I just want to set this statically because I know this is my correct public hosted zone name. And I want to continue using this going forward. So that's the easiest way to kind of get this there. All right. Now what I need to do right now, if you can see, I'm in the P4 server directory, so I need to go back a couple of layers. I think probably maybe about here. One more. I'm gonna go back one more level, and yeah. So now I'm at the root of the directory for the toolkit, and I want to change directory into modules, Perforce, and then examples is where I want to be, and then inside of examples create resources complete, right? Because this is where we are here, and this is where if I kind of just do an ls, you can see these are the same files that I would expect to see as I see over here. So what I want to do from here is first I want to do Terraform init. I have aliases just to make these shorter, but the long way is Terraform init to initialize Terraform and the current working directory, which is why we had to change directory. And we'll let that finish. All right, cool, that's good. And I'll just expand this to make this a little bit bigger. The next thing I'm going to do is plan, right? Create an execution plan. So I have an alias, of course, Terraform plan. You would just need to type out the full words of Terraform plan. So you can see there are 106 resources that are going to be created. You can see these outputs. These are going to be helpful for actually accessing the services. So for auth, the P4 auth, P4 code review, and then this is actually what you would use in P4 admin or P4v to connect to the Perforce server. Okay, that looks good to me. And the next thing I'm going to do is Terraform apply, and I'm going to tack on the auto approve just because I know all of this will go ahead and deploy. Now, as that's deploying, I want to talk a little bit more about kind of what is necessary for accessing the Perforce server and the related resources. So if we look at, I believe it's in dns.tf, and we scroll down, actually it's in security.tf, right? So since we're dealing with networking resources, one common component of networking in AWS is known as a security group. So it's basically a firewall in AWS for specific resources. So what you need to do is for that EC2 instance, there's a security group on it that by default is not going to allow traffic in, right? And that's intentional for security, right? You don't want to open that up to the public internet and allow anybody to attempt to, whether they're successful or not, you don't want them to be able to attempt to connect to your EC2 instance, right? So what we're doing is we're adding a security group to that instance that's going to be using our specific public IP address, right? So you can see here, the first thing that I'm doing is I'm creating a security group. I'm creating an ingress rule, which is going to be allowing 443, so HTTPS and HTTP traffic on port 80 from my specific IP address, right? So definitely read through this and kind of see what's going on here. And the way that I'm doing this is I'm using this data source here, which is going to be fetching my public IP address and using that as the IP address in the security group rules. The way that the module is configured, if we kind of look at main.tf, and if we look for existing, you can see we have a number of existing security groups, and effectively the module is creating some default security groups just for what's necessary for the internal connectivity and routing. And the way that we allow you to choose what IPs should also have access is with these existing security groups. So what this would do is effectively add additional security groups to the resources that the module creates. So for example, in this one with the P4 server config, this would be adding an additional security group to the Perforce server EC2 instance that would allow whatever traffic in that you define in your own security group. Same thing for the P4 auth service, and then the P4 code review service, and then the related load balancers and stuff like that. So that existing security groups variable is how you're going to allow that specific traffic in. So it's really, really important to make sure that you set that correctly. Like I said, by default, if you don't change anything, whoever the IP address or however you're deploying this, their public IP address will be the only resource that actually has access to these, the Perforce resources. So if you deploy it and then, you try to give your team, access, you just give them the endpoint for the P4 server and you're wondering why they can't connect, or maybe if they're trying to go to review.perforce.example.com or auth.perforce.example.com and they're not able to actually hit the service or the web page, that's why. So you need to make sure that you create your security group effectively, and there's a lot of different ways that you have at your disposal for how you actually want to set these security groups. But at the minimum, the way this is right now, for simplicity's sake, is using the public IP address and using that for the security group rules. But a lot of different options, right? You can use prefix lists if you have maybe a network, so like a CIDR range that you want to allow everyone in that CIDR range to allow have traffic into it. There's things like maybe VPN connectivity, so maybe you have the AWS client VPN and people are connecting to the VPC that way, and then at that point it would be private connectivity. So a lot of different options, but just the important thing to note about that. So if you're having connectivity issues, the first thing that I would check would be the security group configuration that you have here. So I'll go ahead and let this continue on to finish deploying, and then we'll make sure that our services are up and running, and we'll use P4V to actually connect to the Perforce server. All right, so it looks like that finished successfully for me. I got my apply complete and I see these outputs here. So let's actually try to go ahead and open these up. So before I do that, let's hop into the console and take a look around. So I'm gonna grab this auth URL here, and we'll flip back over into my browser, just open a new tab, paste this in. And we might give it, sometimes it takes a little bit of time just for the service to finish starting successfully. So we'll let that run. Let's actually take a look around. Oh, you can see it's up now actually. So yeah, helixauthenticationservice is running. If we grab the other URL for P4 code review, grab that here. And we'll open this as a new tab. We have, this one is probably not up just yet, so we'll give this a little bit of time. So we will, in the meantime, let's flip over and kind of look at what was created separately. So if I give this a refresh in my browser here for this public hosted zone, you can see there's some additional records that were created. So we have this perforce and then my domain. This is going to be an A record, which is going to be routing traffic from that is destined for this domain to the public IP address from my EC2 instance, right? And that's exactly what I wanted. So like I mentioned, right, you could use this public IP address. Since this is an EIP, it's not going to change. I could use that to connect, but I'm going to be actually using this specific domain to connect. There's also another record that's going to be routing all.perforce. My specific domain. So basically anything else that has a subdomain in front of that, it's going to be routing that to the network load balancer. So what that's going to be doing is catching the request destined for auth.perforce.mydomain and review.perforce.mydomain, and it's going to be routing it to the network load balancer, right? And if we go into the load balancer, we'll actually take a look in here. And you see we have two load balancers. One is a network load balancer, one is an application load balancer. If we look at the network load balancer, you can see we have a listener, and it's going to be forwarding HTTPS, so that 443 traffic, to the target group, which is going to be the application load balancer. So if we kind of click on this here, you'll see we have a registered target, which is going to be that application load balancer. And then if we look at the application load balancer, you can see we have a default rule, which is just fixed response. But if we click these three rules here, we'll actually see the additional ones here. So basically the default one, if no other rule applies, it's just going to be that fixed response of a 200 status. And then what we have here is it's basically going to route review.perforce.mydomain to the target group for the P4 code review service. And then if it is auth.perforce.mydomain, it's going to route to the service for P4 auth, right? And that's how that's actually going to be going to the relevant ECS services. If we give this a refresh, P4 code review is now up and running. So, or you can see here, the naming still shows helixswarm. Like I said, slight branding change, but we have these running, right? So we have the auth service for helixauthenticationservice, or P4 auth is the new name. And then we have swarm also running, which is now P4 code review. Now let's actually use P4V and let's connect to the Perforce server. So to do that, I'll flip back over to VS Code, and I'm going to grab this URL, for the server connection string. So I'll grab this, and then I'm going to open up P4V. And you can see I already had this up in the past. But what I'm going to do is, assuming it was you and this was the first time, you would paste in that value here, which of course would be different depending on whatever your domain stuff is set to. And then we're going to have the username, and then we're going to be prompted for a password as well. So first thing I'll do is I want to flip back in. The default user that is configured with the module is going to be Perforce, and then the password is actually going to be stored as a secret in AWS Secrets Manager. So if I flip back into the console and I'll just search for Secrets Manager, you can see here there's a couple of different ones that are in here related to this. So for context, right, with the module, pretty much anything the module starts or creates is going to start with CGD for cloud game development. It's configurable, of course, depending on whatever you set as that project prefix, but just to make it easy for you to find what was created, that's the flow that it'll take, right? So what we want to do is, for the P4 server super user is what we want to use this for, right? So like I said, the username, if we click in here and click retrieve secret, you can see that's Perforce by default. But what we need is the super user password. And so we're going to click retrieve the secret value. I'm going to grab this value here, and I'm going to use this to actually authenticate into P4V. So now if I flip back over into P4V, I'm going to, again, this is the correct server URL. This is the user information. I'm going to click OK. And then I'm going to trust this fingerprint for the specific server and click connect. And now it's asking me for the password, which I'll paste in and click OK. And now you can see I am authenticated into Perforce, right? So this is some stuff on my local file system. Then you can continue on and do any of the other configuration that you might want to do for your Perforce server. So with that being said, as a recap, we have the Perforce server running. We've used P4V to connect, and we also have Helix Authentication Service and helixswarm configured, all in just a couple of minutes. So that about does it for today's video. We've successfully used the Cloud Game Development Toolkit to deploy Perforce on AWS. We've then validated the deployment by using P4V to connect to the Perforce server, and have also tested connectivity to P4Auth and P4 server. If you found this video helpful, please like and share with others you think may also get value from it, and subscribe if you'd like to see more content like this in the future. That's all for now. I'll catch you in the next one. Peace.